this is for Year 11 methods. We're going to look at question 5 and question 6 from exercise 6H. Now the question goes that we've initially got 500,000 bacteria at 12 p.m. on Sunday. The culture increases by 10% per every hour. At which time would the culture exceed 4 million bacteria? So let's use our basic model. Population equals A times B to the power T. Now I know my initial population is 500,000, so that's automatically my A value, because again, if T equals 0, then the population, which is 500,000, equals our A. So I know automatically that A equals 500,000. Now a B value we can get from this statement. It increases 10% per hour. So for every hour, it increases 10%, which means 1.1 as a base. So from the question itself, I can specify my model straight away. Now we need to use our model. We need to use the model to figure out what we want, which is what time will the population exceed 4 million bacteria. So we're given that n equals 4 million. We're trying to find at what time that occurs. So simply stated, we need to find when I'm missing 0 here. When the population, in terms of hours, does the culture reach 4 million? 1.1 to the power. So when I solve that, I go interactive advanced solve. I get 21.81. So in terms of hours, 21.81 hours, which simplifies to 22 hours, because it's talking about hours, so it's assumed to be a discrete value. So you go to the nearest hour to ensure that you go above the population. So for question 6, so this is for question 5. For question 6, we're given information about the temperature. So when a liquid when liquid is placed inside a refrigerator, the temperature time is given by this formula. So they've given us a model. So this is the model we need to use. Minus KT. Now, the temperature initially means at the very start. So T equals 0. So when T equals 0, the big T, the temperature, is 100. When we sub in 0, that goes to 0. So 10 to the power 0 is 1. And we know T is 100, so T0 equals 100. So we know T0 is 100 straight away, based from our initial value. Now we're given another piece of information. It drops to 40 degrees in 5 minutes. So the temperature in 5 minutes is 40 degrees. And we know T is 5 because T is in minutes. And all I'm doing is solving for my K value, because that's not known. I can't use that equation until I know my K value. So I go 40 equals 100 times 10 to the power negative KT. Remember to put brackets in, because we can easily run into problems if we don't put the brackets in. And our X, or T value, is 40. I should put that there. T value is 5, sorry, 5. times 5, and we're trying to solve for x, or t in our case, but I'm just using x. And I get 0.0796, 0.0796, so k equals 0.0796. Now, since I've got my k value and my t0, my equation is specified. And that's 10 times negative 0.0796 t. So that's my model specified. I need to find what I need to use the model for, which is find the temperature of the liquid after 15 minutes. So at t equals 15, I just sub that into my model. 10 minus 0.0796 times 15. So all I'm doing is summing into the model. 10 to the power brackets negative 0.0, or I can simply paste this on. Times 15. So we get the temperature to be 6.4 degrees after 15 minutes, which is our answer.